This is my third video on applications of derivatives focusing on related rates. For example, gravel is being dumped from a conveyor belt at a rate of 120 feet cube per minute, forming a conical pile whose base diameter is 2 times the altitude. How fast is the height changing when the pile is 15 feet high? So let us consider this conical pile here. Okay, so the volume of this pile of gravel is changing at the rate of 120 feet cube per minute. So that will be our derivative of the volume of this cone, of this conical pile with respect to time. That's 120 feet cube per minute. And we are using the positive sign because if the conveyor belt is dumping on it, then its volume is increasing. And then, according to our problem also, the base diameter, here, the base diameter is 2 times the altitude. So let us suppose this is our altitude, and that is h. So the base diameter is twice h. Okay, so we're looking for how fast the height is changing when the pile is 15 feet high. So we have an h given also as 15, the height of the conical pile, and we are looking for the derivative of the height with respect to time. So what formula are we going to use? What will relate the volume with the height? Okay, so the volume of a cone is equal to 1/3 pi r squared h. Okay, as we can see, we don't have any radius here, but we can actually relate the radius to the diameter, right? So we know that, again, the diameter is twice the radius. And in this case, the diameter here is 2h. So that is the twice the radius. So that means that h is just the same as r. So we will just replace r with h. So we have the volume is 1/3 pi h squared h. Or we have the volume is 1/3 pi h cubed. And this is what we are going to differentiate with respect to time. So we have dv dt is equal to 1/3 pi, and that's 3h squared, derivative of h with respect to time. And we can see here that we can cancel 3. And then we will just have dv dt is equal to pi h squared dh dt. And let's plug in the data that we have. dv dt is 120, and then equals pi, we have an h, and we're looking for dh dt. So h is 15. So if we just divide both sides by pi 15 squared, then we can get our dh dt already. Okay, so canceling this out. So that's 120 over 225 pi. And that is approximately 0.17. So our derivative of h with respect to time is 0.17. Our unit of measure for height, that's feet, and for time, that's minutes. So 0.17 feet per minute. It's positive. That means as the volume is increasing, the height is also increasing. And the increase is at the rate of 0.17 feet per minute.